Okay, we're going to be looking at three different kinds of discrete probability distributions. They are binomial, Poisson, and geometric. Today we're just going to focus on the binomial distributions. So this is 4-2, day 1, binomial, probability, experiments first. That's what's going to be the tricky part when the test comes along, is distinguishing which of the three distributions it is. Is it binomial, is it geometric, or is it Poisson? So, and they're all going to be mixed together, I think, Tuesday. But today, just binomial. So what makes an experiment a binomial experiment? Several things. First of all, the experiment is repeated for a fixed number of trials. You know exactly how many trials you're doing. One of the other distributions, you don't know how many trials you're doing. You do it until you succeed. Okay, so you know exactly how many trials you're doing. And each time you do a trial, there's only two outcomes. Only two outcomes for each trial. Thus the name binomial, bi meaning two. What do you think those two outcomes are? Nope. Success or failure. You either succeed or you fail. And the probability of a success is the same for each trial. Okay, if those three things are met, you've got a binomial experiment sitting in front of you. Okay, there's going to be a formula that we're going to use to find probabilities later on, and we need to identify four things in our binomial experiment, and we'll label them. So the variables for this, we'll call them variables. We are going to let n represent the number of trials you're doing. We are going to let p represent the probability of a success. Q is going to represent the probability of a failure. And X is going to represent the number of successes. So far, so good? Nothing too tricky in there? Okay, I'm going to describe an experiment. I want you to tell me if it's binomial. If it is, identify the four variables. If it's not, then tell me which of the three things isn't being met. you. So dot, dot, dot will answer the second part of the question. Okay. Oh, I hit the right page. Okay, here we go. We are going to take a multiple choice quiz. Take a multiple choice quiz that has 10 questions. 10 questions. Each question has 4 possible answers, A, B, C, D. Okay, to complete the quiz, you randomly guess the answers to each question. The random variable represents the number of correct answers. So the random variable is the number of correct answers. Correct answers. So that's what I'm looking to have happen. I want to get a correct answer when I take the quiz. I either succeed at that or I fail at that.
What's the definition of just a random variable?
That's the outcome. Just the outcome. So for us, the x is the random variable. We'll get to it in a minute. Okay, let's decide if this is binomial. 3 things have to happen. Do I know exactly how many trials I'm doing? I'm doing 10. I'm answering each question. So answering a question is a trial. I'm guessing the answer to the question. So yes. Are there only 2 outcomes each time? Success and failure? So when I answer a question, what can happen? I either get it right or I get it wrong. So that's success and failure. All right. Is the probability of success the same on each question? Because only one answer is correct out of 4. All of them have the 4. So yes, is it binomial? Absolutely. Yes, it's binomial. So you have to look at those 3 qualities, I guess, to see if it's binomial. Okay, now that it is, I want you to be able to pick out N, P, Q, and X. N is the number of trials. How many trials did you say I was doing? 10. So N is a 10. P is the probability of a success. What's the probability that I succeed on each trial? 1 out of 4. 1/4. What's the probability that I fail on each trial? 3/4. Agree that P and Q are always going to have to add up to 1? I sure hope so. X. X is the number of possible successes. This is not a one value thing. So think, what's the least number of successes I could get on this experiment here? 0. I could get none of them correct. What else could happen? I could get all of them. Anything else? I could get 1, or 2, or 3, or 4. So I can get anywhere from 0 successes all the way through to 10 successes. So X takes on the values all the way through 10. So there are how many outcomes there? Or not outcomes, but how many possibilities? How many numbers are there from 0 through 10? 11. 11 different values that X can take on here. Because X counts the number of successes. Are you okay with that? Okay, moving on then. Okay, what we're working on, making our way to is making a binomial probability distribution. And we have a binomial probability formula. I'm going to say very close, yes. Binomial probability formula. give the probability of exactly X successes. Okay. So like, if I took that 10-question quiz, I could say, what's the probability that I get 5 of them correct if I guess? So X is a 5. And this formula would help me find that probability. So the probability of X successes is this nice little formula. N, C, X, N trials combined X at a time, multiply that by P to the X, and then multiply that by Q to the N minus X. Okay. That wouldn't be horrible to have you do by hand, because you're going to know the 4 values, N, P, Q, and X, but the nice programmers at Texas Instruments made your calculator to do all of this statistic stuff. So they have this built in to a nice program that we're going to use. So you are not going to have to do this by hand formula. I just wanted you to see it. Okay, I'm going to write down what it is, kind of tell you where it is, and we'll actually do it in a minute. So where it is on the calculator. So if you don't have a graphing calculator, you are going to be stuck doing this by hand formula. Okay. So it's under, and I'll show you later in a minute, it's under distribution, D-I-S-T-R. Then you're going to go down to binom PDF, and that stands for the binomial probability distribution function. PDF is probability distribution function. And then you just have to feed it the right values. Well, if you take a look at the formula, what's one thing this formula needs to know? It has to know how many trials you're doing. That is the first thing you have to feed it. So you have to feed it in the right order. Tell it how many trials you're doing. What else do you think it needs to know? It does, but not yet. P, it needs to know the probability of a success. Do you think it needs to be told what Q is?
No.
Why not? Because it adds up to 1. So in the program, it can figure out the Q. So it does figure out the Q all on its own. Nice. And then you tell it X. And it plugs into this formula and cranks it out and gives you the answer. Easy peasy. So X is the number of successes, remember. Whatever we're looking for, like that 10-question quiz, it could take on 0 or any value through 10. So what's the probability that I get all 10 correct by guessing? I can plug those numbers in here. 10 trials, 0.14, 10 successes, and it will give me the probability that I guess all 10 correct. Not very likely. What did I say?
0.14.
Oh, 1/4, 0.25. Okay. So let's try one. I'm going to change it up. Okay, we're going to have a deck of cards. We are going to pick a card. Five times with replacement.